All right, so this lesson is going to show you how to convert stuff. It's going to start simple and it's going to slowly increase its difficulty. I would say some people are going to find easier methods. What at first it seems easier, right? You're going to find a faster way, and that fast way is going to be like, oh, this my way is better. I would say be careful with that. The way I'm showing you is a good way of thinking about it, where you can reason through it, right? If you're doing stuff and you don't know the reasoning and you can't really, it only works sometimes, it doesn't work all the time, then that's because there's a gap in your understanding and you're not sure what you're doing. So I'm going to show you a way that for super easy problems, it seems a little complicated, like it makes them a little bit more complicated, but on more difficult problems, it makes it a whole lot easier. So if you can learn it this way, I think you'll understand the conversions quite well. So let me come over here and just kind of do some scratch work for a minute. So let's say I have this number, right? So 5. And one of the things we can, so if we have a number by itself, no equal sign, then this is called an expression. And in math, when we're dealing with an expression, we can't change the value of an expression, right? I can't make the 5 6 just by doing some adding. I can't just go adding to it and say, okay, it's still the same. You can't do that, right? You got to keep the expression the same. You can change the way it looks, right? I could say 5x divided by x, and that's still going to, the x's would cancel out, and that's still 5. So that's okay to do. Or I could say, 5 times 20, and then whatever that is divided by 20, that's still going to be 5, right? It might look different. 5 times 20 would be, 100 divided by 20. That doesn't look like a 5, but it still is a 5, right? So hopefully you get where I'm coming from. Now in conversions, we're not multiplying and dividing by the same thing. That's where the converting part comes in. So if I have 5, and let's just say I want to multiply, and now I'm thinking about money, right? I'm thinking about maybe you can change it however you want, as long as you change it and unchange it equally. So here's what I mean by that. I can multiply this by 4 quarters, right? As long as I divide it by 4 quarters. Now, you would say, well, that's kind of like the last one. But what if I didn't, divide it by quarters? What if instead I divided it by dimes, right? Dimes. Well, now it's not 4 anymore. Now it's 10. So would this still be the same? So if I had 5 times 4 quarters, which would be, 20 quarters. Yeah, I know I spelled it wrong. Whatever. Divided by 10 dimes. Is this still $5, right? Yeah, it's still $5. So hopefully that makes sense. You can express, if you have an expression, you can do whatever you want. You can multiply it by whatever you want, as long as you divide it by that same thing. Or you could add something to it, as long as you subtract the same thing. And as long as whatever you're multiplying and dividing by is equal, right? They don't have to look the same. I don't have to say 5 times 4 divided by 4 every time, but I do have to make sure that whatever is in the numerator and the denominator, they're equal. So 4 quarters is the same as 10 dimes. That would be okay, because it doesn't truly change the value. It just changed the way it looks. Okay, so with that said, let's talk about this problem. So the first one says 15.7 quarts to liters. So I'm going to start with 15.7, and we're talking about quarts. And I know I want my final answer to be in liters, right? I want it to be liters. So here's how I deal with these problems. I always create a fraction. And then I think, okay, what am I going to be multiplying? I'm going to multiply it by something else. And because I know I want my quarts to cancel out, that's what I'm trying to get, make go away completely. And I'm trying to convert it to liters, right? From quarts to liters. So I do need to find, what is a relationship between quarts and liters? And up here, since they're both volume, you can find that right there. And we see that 1 liter is equal to 1.057 quarts. So I know I want to get rid of the quarts. So if I'm multiplying by something, in the denominator of that fraction that I'm multiplying by, I want to have quarts. Why? Because if I multiply and when I have, 5 divided by 5, that cancels out, right? Or if I have 5xy divided by 2x, the x's cancel out. Same thing with conversions, right? We're trying to think about a way to cancel them out. So if I say quarts in the denominator, then the quart will cancel out. And I know there's 1.057 quarts for every 1 liter. Well, now the quarts will cancel out when I, multiply together. And then I got 15.7 and times 1 liter. So that's 15.7 liter divided by 1.057. There's no units here. So this just leaves liters as my only unit. And then I can say, all right, 15.7 divided by 1.057, and that gives me 14.853, right? And then you might be thinking and we're talking about liters, right? And what am I rounding to? Well, 15.7, that was quarts. That's what we had to begin with. When we converted that to liters, we know there's 1.057 quarts. So this gave me 4 significant digits, right? So it's converting, with accuracy. We know this was accurate, and then it's converting to this level of accuracy. I'm gonna round it to, 4 significant digits. So I'm gonna say right here, that would be 14.83 liters. All right, 14.83 liters. Let's do another one. $7.5, or I'm gonna skip that one. Well, no, I'll still do it. It's pretty similar. So 7.5 watts, and I want my final answer in horsepower, HP. So we look for a relationship between watts and horsepower. Watts, horsepower, we're talking about energy, right? I create a fraction. I think about, I want my watts to cancel out, so I know they're going to be in the denominator, and I know that's 746.0, so 746.0 watts, and that's 1 horsepower. Now I'm trying to cancel stuff out. That cancels, right? We multiply together, and I got 7.5. 7.5 times 1 divided by 746.0, and that gives me 0.0100536, and we're talking about horsepower, HP, right? And then if you're trying to determine what to round to, I'm just going to go with 4 significant digits. The problems, hopefully, they will tell you what to round to, so you can focus on conversions and you don't have to think about when converting one decimal to another that's equivalent that has, however many significant digits, but I'm still dealing with the numbers from before. That's a little bit complicated, so let's not worry about that. Instead, let's focus on conversions. So I'm going to say this is 4, and I'm going to say 0, 1, 0, 1, right? And we're talking about horsepower. So 7.5 watts has 0.0101 horsepower. So, okay. Let's get out of that. Let's try another one. Let's look at another one. So 245 square centimeters to square inches. All right, 245 centimeters square, right? Now, centimeter square means that we're talking about, might simplify this to think about centimeters times centimeters, right? That's centimeter square. Or and I know I want my answer in the form of inches squared. So inches squared. All right. So let's work this out. First over 1, and then I'm thinking about what I multiply by. Well, I need to think about the relationship between centimeters and inches, right? And I need my centimeters to go away, so I know 1 inch is 2.54 centimeters. So in the denominator, I'm going to say, oh, I want my centimeters there, and I say 2.54, and that's 1 inch, right? And that cancels out with this one. And now I got centimeters and inches, but I just need inches. So I got to do it again. I want to cancel this one out. So I have to do that again. 1 inch over 2.54 centimeters. Now that one cancels with this one, and I have inches squared left over. So I know this is going to be 245 times 1 inch. So inches squared divided by 2.54 times 2.54, right, equals 245, 2.54 times 2.54, and that gives me 37.975 inches square. And that's, yep, so 2.54, 245. Yep, and that's the easy way to think about it. Or I think it is. Hopefully you think it is too. I'll do one more and then I'll leave it at that. So we'll do miles per gallon to kilometers per liter. All right, so we'll see two different things being. So we're talking about 25 miles per gallon, and we want to convert it to kilometers per liter. So 25, mile over gallon, right? That's mile. So you're going 25 miles. I'll write it like that first, gallon. All right, so and we want this converted to kilometer per liter. So this is how I'm going to do this. 25, and we're talking about mile. And since that gallon's in the denominator, I'm going to just write it as over 1 gallon. All right, this is where this method shines at, right? If you felt like this method is not for you so far, well, don't count it out yet, because I feel like this is where it shines at. Now, we got to think about a relationship between two things, miles to kilometers and then gallons to liters. So it doesn't matter which one you start with first. I'm just going to do miles because that's the first one, right? There, miles to kilometers. Here it is right here. I want my miles to go away and I want my kilometers to be there. So I know I need my miles right here. And then my kilometers, in this case, 1 kilometer is equal to 0.6214 miles. The miles cancel out, and now my distance will be in kilometers. All right, and now I want my gallons to cancel out, and I want them to become liters. So I got to look up. Over here I see gallons. All right, let me change my color. Over here I see gallons to liters. I know I want gallons to cancel out. The only way it cancels out is if it's in the numerator. So I got 1 gallon, which is equal to 3.785 liters. The gallon cancels with this over here. Now this miles per gallon is canceled out completely, and I'm left with, in the numerator, right, I got 25 km, kilometers, right, times 1, and then I got 0.6214 in the denominator times 3.785 liters, right? So my final answer, I'd say 25 divided by 0.6214. Times, in this case, I'm actually 0.6214 parentheses 3.785, right? And this gives me 10.629. I'm just leaving it at that 0.629, and we're talking about kilometers per liter. Bam. Pretty straightforward. All right, so that's what I think is the best way to do conversions. I've seen other people do it other ways that is essentially this, but they just don't structure it the same way. I feel like there's success in the structure. So hopefully you can find some success in that too. All right.